Well, scientists have successfully removed a piece of faulty DNA which causes heart disease from an embryo for the first time. The development could be the first step towards preventing thousands of disorders, from breast cancer to cystic fibrosis, which are passed down through the generations. Well, does the procedure throw up any ethical issues? Let's speak to Dr. Peter Saunders, who's the Chief Executive of the Christian Medical Fellowship. Dr. Peter, thank you so much for joining us. 10,000 genetic disorders could be eradicated. Surely this is a very, very good thing.
Well, there's huge potential here, and I think this is a big advance on what we currently do, which is adopt a kind of search and destroy mentality of identifying embryos and fetuses that have genetic disorders and simply disposing of them or aborting them. What this does, which is very different, is that it finds a faulty gene in an embryo and corrects it. And certainly this group have made a big advance on any previous work in this area. By doing it much earlier, before fertilization, they've managed to produce correct repairs of this particular faulty gene in 72% of cases. Of course, in 28% it didn't work. So it's an improvement on pre-implantation genetic diagnosis and amniocentesis and abortion, but I think there are still questions about it, both in terms of safety and also in terms of ethics.
Okay, well, let's come to those questions in a while, but where do we go from here following this research?
Well, I think a lot more work needs to be done. What they have demonstrated is that it's possible to cut out a piece of faulty DNA and replace it with normal DNA, and in 72% of the embryos they dealt with, actually to repair them so that all the cells in those resultant embryos have been normal, and there haven't seemed to be any off-target effects on other areas of the genome as well. So that's a huge advance. But obviously it needs to be, the work needs to be done in much more detail, and there are concerns about the whole process as it is. Dozens of embryos were created and destroyed in this process. Each one of those was an individual human life, and there were also eggs harvested from 12 different women in order to do this research, and that raises questions about the exploitation of vulnerable women. There's still a ban in over 40 countries in the world on germline therapy, which means that any change in an embryo or in sperm or egg could potentially be passed on down the generations, and people are very worried about introducing genetic changes into the population, which it might be very difficult to get rid of at a later stage. But this latest experiment does show that it can be done in principle more accurately. I think the other worry about this is what might happen if this technology were to get into the wrong hands, in the hands of rogue scientists who are not interested in using it to treat very, very sick embryos with fatal diseases, but are actually looking to enhance intelligence or athleticism or to redesign human beings in some other way. So it's potentially also the thin edge of the wedge to design a baby. So there are lots of big questions about safety and about ethics that we need to look at before we can take this whole process further. So it's a first step with promise, but questions remain.
Looking at that process, I mean, how difficult would it be to recreate it? You're talking about these rogue scientists. I mean, how difficult would it be for someone who is unethical to get their hands on this sort of a process and progress?
Well, we're talking here about effectively porter cabin technology. If you have the right equipment, you've got access to the CRISPR technique and a laboratory, it's very difficult to provide proper surveillance or regulation in this sort of area. And in states where there's not good regulation, or where people are motivated perhaps by financial incentives as well, things could really get away. So it would have to be incredibly carefully legislated, but that's only if it could be shown to be completely safe, and we're a long, long way from that yet.
If we live in a world where female embryos are aborted simply for being female, I mean, do you think it takes a huge stretch of the imagination to believe that people would opt for genetically modified babies?
Oh, I think there are people already who would love to have genetically modified babies with certain degrees of intelligence or athletic ability or any other chosen trait, there's no question that there's a market out there for it. And sadly, there will be scientists who are prepared to bend the rules and cross ethical boundaries in order to provide it. And I suspect that there will be biotechnology companies as well. So there are huge ideological and financial vested interests in this whole area, which does make it very difficult to legislate or regulate safely. And this is the danger, is that you've got the camel's nose or the thin edge of the wedge, that by allowing something in very restricted circumstances, you could be opening a whole Pandora's box of frightening possibilities. And that's why we need to be guarded and careful and proceed very, very slowly and discuss and consider all these very important ethical questions. My worry is that we'll see the Nuffield Institute and the Human Fertilisation Embryology Authority and the Science and Media Centre getting together to change public opinion on this very quickly, and that we'll be making steps down this road long before we're ready to, or before it's safe to. So my fear is that we'll see the wool pulled over the eyes of the British public if we're not careful. This is an exciting development with potential, but we need to tread very, very carefully indeed.
Okay, thank you so much, Dr. Peter Saunders. Thanks for chatting to us this afternoon.